Here let us see a very important question from the chapter Mathematical Induction. Here question is, prove by the principle of mathematical induction for all n belonging to the set of natural number. Here statement is 1 plus 3 plus 3 square plus 3 cube up to nth term 3 to the power n minus 1. This is equal to 3 to the power n minus 1 divided by 2. So this is the mathematical statement which is given and we have to prove it by the principle of mathematical induction. So very interesting solution. Let us see. Here mathematical statement is denoted by Pn. Okay, general notation. So here Pn is statement is 1 plus 3 square plus 3 cube up to 3 to the power n minus 1, and right hand side is 3 to the power n minus 1 divided by 2. Let us call it relation number 1. So you know how we can solve it, how we can prove it. We have done so many questions in previous video of the same pattern, that first of all we have to show that P1 is true. That will be our first step. We will put n is equal to 1. So we will get P1. And we have to show that P1 is true, means LHS will be equal to RHS, first step. Second step, you have to assume that PR is true. We will put n is equal to R and we will get expression and we will assume that that is true, correct? And third and last step, you have to show that PR plus 1 is true, means we have to put n is equal to R plus 1 here and we have to show that LHS is equal to RHS. So only 3 steps are there, and after completing all these steps we will write one line statement at the last, that therefore by the principle of mathematical induction the statement Pn is true for all n. Okay, so now let us start it. Step number 1, to show that P1 is true. To show that P1 is true, and for showing this we will putting n is equal to 1 in relation number 1. Okay, so how much we will get? Putting n is equal to 1, here total number of terms is n, but we are putting n is equal to 1. So we have to take only one term, first term only here. So this statement P1 putting n is equal to 1 now becomes n is 1, so we have to take only one term here. So this is 1, first term is 1, and right hand side putting n is equal to 1, so 3 to the power 1 minus 1 divided by 2, or we are getting 1 is equal to, this is 3 minus 1 is 2, 2 by 2 is 1. So therefore we are getting LHS is equal to RHS, and therefore P1 is true. P1 is true. So first step is over. Now second step, we have to assume that PR is true. Assuming PR is true. So here we will putting n is equal to R in relation number 1. We will get here PR, which is equal to 1 plus 3 square plus 3 cube plus up to 3 to the power R minus 1 is equal to 3 to the power R minus 1 divided by 2. Let us call it relation number 2, correct? Now third and last step, we have to show that PR plus 1 is true. To show that PR plus 1 is true, and for showing this we have to put n is equal to R plus 1 in relation number 1. So putting n is equal to R plus 1 in relation number 1. Okay, we'll get here PR plus 1. This is the statement. In place of n we are putting R plus 1, and we'll get here 1 plus 3 square plus 3 cube plus 3 to the power r minus 1 plus, this is not last step. At the last step, you have to put n is equal to r plus 1. So this is second last term. Okay. And last term is 3 into, in place of n, you put r plus 1 minus 1. This minus 1 is equal to 3 to the power r plus 1 minus 1 divided by 2. So you have to show that this relation is existing. This is true. We'll start with left hand side here and we will show that LHS is equal to RHS. So here left hand side will be 1 plus 3 square plus 3 cube up to 3 to the power r minus 1 plus last term is 3 to the power r. Since here plus 1 and minus 1 will be cancel out, and this is equal to, you see relation number 2, up to this much part we are having a value 3 to the power r minus 1 by 2. So for this much expression from relation number 2 we can write 3 to the power r minus 1 by 2. So this is 3 to the power r minus 1 by 2 plus 3 to the power r. We are writing this by relation number 2. Okay, and this is equal to, we will take the LCM here. So LCM is 2. Here 3 to the power r minus 1 plus 2 into 3 to the power r. Let us simplify it. 2 to the power 3, 2 into, here into is there. So 2 into 3 to the power r and 1 3 to the power r, means 3 into 3 to the power r minus 1 divided by 2, and this is equal to, you multiply 3 with 3 to the power r, it will be 3 to the power r plus 1 minus 1 divided by 2. And you see this is the right hand side, this one is the right hand side, we had to prove it. So this is right hand side, therefore we are getting here LHS is equal to RHS. Therefore LHS is equal to RHS. It means PR plus 1 is true, that is PR plus 1 is true. So all the 3 steps are over here. Now finally we have to write the statement that therefore by the principle of mathematical induction, principle of mathematical induction, this statement Pn is true for all n. Okay, so now it has been proved, we got the result. Okay, so very interesting, very simple solution, and we have to take only 3 steps, do 3 steps, and we can prove this question very easily. So hope you have understood it very well, and these questions are very interesting. So remain in touch with my videos and enjoy mathematics learning. Wish you all the best.